Welcome to you all. Hope that this session will give you more contextual understanding about the other relevant time analysis and determination in project network analysis. This video is a continuation of previous videos as a part of network analysis. This covers the following as the main sections in time analysis. Initially, the time analyses and other relevant aspects. A earliest starting time, EST. A latest finishing time, LFT. And other related aspects of duration. Also, you are kindly advised to watch relevant previous videos if you need clear understanding of this illustration. Time analyses and some relevant aspects. In network analysis, it is important to measure the completion time of an activity and a project in consideration of its various time estimates. Making decision on completion time of a project is vital by comprising all relevant project activities. In this context, two basic durations need to be calculated in relation to every activity in a project. They are namely, earliest starting time, EST, and latest finishing time, LFT. These durations of an activity would be shown in its respective head and tail events. Hence, in this video, together with EST and LFT, determining the other two durations, especially earliest finishing time, known as EFT, and latest starting time, known as LST, is shown to move into the other topics of project network analysis. Earliest starting time, known as EST. With the determination of duration of each activity, it is possible to determine the project duration. The project duration can be first determined based on this EST. The EST is the duration at which an activity can immediately be started without delay. In this context, the EST of the initial activity or activities of a project is 0 that will be placed on the left side of initial event of the project. This EST equals 0 in the first event will be added to the durations of subsequent activities in order, and the sum will be placed on the left side of next subsequent events, respectively. If two or more activities are reaching in an event, the highest duration from the various paths is the EST of the event and of the next subsequent activity or activities. The EST of activities can be placed in a network diagram based on the durations of activities, in hours, days, weeks, months, etc., in a project. The placement of EST is shown next in a network diagram, which is derived from the example presented in the previous video. You can find the previous video at this link, which is given with the video description. This is the network diagram derived from the example in the previous video. The animation shows how the EST of every activity is determined. You have to carefully watch how EST for an event is determined and where those calculated values are placed. In the first video of Introduction to NWA, it is shown that an activity has a tail event and a head event. The EST of an activity's tail event will be added to the activity duration, and the sum will be placed in the activity's head event. Now you can see the durations of tail events, activity durations, and the durations of head events for activities A, B, C, and E. Also, note that EST in event 1 is 0. Subsequently, adding the activity duration to EST equals 0 results in EST of the activity's head event. This is known as forward passing. Activity A finishes at its head event 2. The duration to complete Activity A is 10 months. Therefore, the EST of Activity A's tail event, 0, is added to the activity duration, 10, and the sum, 0 plus 10 is equal to 10, is placed as EST in Activity A's head event. It is notable that the EST of Activity A's tail event is the EST of Activity A. Similarly, the EST of Activity A's head event is considered as the EST of Activities C and D, which begin from Activity A's head event after completing Activity A. In the similar way, all EST of other events, from 3 to 7, should be determined. Also, to begin Activity G, Activities D and E need to be completed. Note that there are two paths. They are A to D and B to E to reach Event 5. Therefore, in this forward passing, EST of Activity G needs to be placed on the left in Event 5. The EST of Activity G is the highest duration in comparison of both paths. From path A to D equals EST of Activity D plus duration of Activity D equals 10 plus 5 is equal to 15 months. And this is compared with duration. From path B to E equals EST of Activity E plus duration of Activity equals 11 plus 10 is equal to 21 months. Hence, the highest 21 months from path B to E is placed on the left in Event 5 as the EST of Activity G. Importantly, it is important to consider and compare the durations of three paths before beginning of Activity H. They are Path 1, A, C, and F equals 10 plus 9 plus 8 is equal to 27 months. Path 2, A, D, and G equals 10 plus 5 plus 10 is equal to 25 months. And Path 3, B, E, and G equals 11 plus 10 plus 10 is equal to 31 months. In the paths, before starting Activity H, 31 months is the highest that is the EST of Activity H and needs to be placed on the left in Activity H's tail event 6. You may see the diagram if needed. All these above imply that A. On one hand, from completion of Activity A, one path proceeds on with activities C, F and H, and other path is with activities D, G and H. Proceeding from Activity A with the path of activities C, F and H needs 32 months, that equals to 10 plus 9 plus 8 plus 5. And with the path of activities D, G and H needs 30 months, that equals 10 of A plus 5 of D plus 10 of G plus 5 of H, to complete the project. And B, on other hand, from completion of Activity B, another path proceeds on with activities E, G and H, and this path needs 36 months, that equals to 11 of B plus 10 of E plus 10 of G plus 5 of H, to complete the project. Therefore, among these three paths, the maximum duration path of 36 months from 11 of B plus 10 of E plus 10 of G plus 5 of H needs to be placed on the left in head event 7 of Activity H. This 36 months is the completion duration of the project. Latest finishing time, known as LFT. For the purpose of identifying the decisive path to complete a project, it is important to determine the latest finishing time, LFT, of every activity in the project. LFT is meant for completing an activity with delay if possible. The determination of LFT for every activity takes place from the final event towards initial event of the project through the activities and their respective events. This is called backward passing, from the project end event to start event. According to the example, the LFT of every activity is placed on the right in an event as in shown in the image next. The network diagram shows determining LFTs for activities. For determining LFTs of activities in a project, it is important to consider first the EST placed in the last event of the project. The same EST duration needs to be placed on right in the last event of the project. In this example, note that the duration 36 months of a state on the left in Event 7 is placed on the right in Event 7 as LFT. Further, 31 months is placed on right in tail Event 6 of Activity H. This has been processed by subtracting the duration of the last activity, in the example, 5 months of Activity H, from the LFT duration in the activity's head event, that is 36 minus 5 is equal to 31, and placing this result 31 on the right in its tail Event 6. However, while passing backward via activities C and D, Event 2 is common for the both activities. It is important to consider which backward passing results in the minimum LFT duration for Event 2, either from activity C or D. In this example, for activity C, its duration of 9 months needs to be subtracted from the LFT of 23 months in its head event, that is, 23 minus 9 equals 14 months. Similarly, for activity D, its 5 months duration is subtracted from the LFT of 21 months in its head event, that is, 21 minus 5 equals 16 months. By comparing these resulting durations, 14 and 16 months, the minimum duration of 14 months has to be placed as LFT of tail Event 2 on its right side. This implies that LFT of activity A is 14 months. Similar approach must be applied, while passing backward towards Event 1 from Events 2 and 3 in consideration of activities A and B respectively. For activity A, its duration is 10 months subtracted from the LFT of 14 months in Event 2, and this results in 14 minus 10 is equal to 4 months. For activity B, its duration is 11 months subtracted from the LFT of 11 months in Event 3, and this results in 11 minus 11 is equal to 0 months. Comparing these resulting durations, 4 and 0 months, the minimum duration 0 is placed as the LFT of tail Event 1 of activities A and B. In this example, you may note that the EST and LFT in events are the same along the path of activities B, E, G, and H. This path of 36 months should be considered as the main path, that is known as the critical path, for completing the project. Further, no activity on the main path can be delayed in its completion duration. However, the activities along this longest duration path, known as critical activities, are therefore very important. The thickest arrows in the diagram indicate such activities, B, E, G, and H, and the critical path for completing the project. These critical activities cannot be delayed if the project needs to be completed in 36 months. The network diagram shows determining LFTs for activities. Some other important aspects of durations. First, the EST and LFT in an event are for two different activities, not for events, and please correct the mistake in typing. For an instance, consider Event 4 and its related activities. Accordingly, the respective illustration is given. Here, Activity C connects to Event 4 and Activity F starts from Event 4 as well. Even 4 has three components. At the top, Events Index, 4, on its left the EST of Activity F, and on its left LFT of Activity C. This is how the values in every event should be understood in relation to its connecting activity or activities. You can observe this approach for the durations of activities in the example given. Second, the tail and head events of activities, which constitute to the critical path and project duration, definitely have the EST and LFT individually equal. In this example, activities B, E, G, and H are the critical activities in order, and you can observe that their connecting tail and head events numbered 1, 3, 5, 6 and 7 respectively have both EST and LFT equal. However, note that an activity does not necessarily need to be a critical activity on the critical path, though it has equal EST and LFT of its tail and head events individually. Third, as every activity has its EST and LFT in its head and tail events in a network, it is indirectly understandable that there are earliest finishing time, EFT, and latest starting time, LST, for the activity. In this context, the difference between EST and EFT of an activity is the activity's completion duration, where EST of an activity, say A, plus duration of the activity, say TA, equals its EFT. That is, EFTA equals ESTA plus TA. Similarly, the difference between LFT and LST is also the activity's duration, where LFT of an activity, say A, minus duration of the activity, say TA, equals its LST. That is, LSTA equals LFTA minus TA. Notably, except for the activities that cannot be delayed on the critical path, it is possible to determine the delay duration, known as float, of every other activity, based on these 4 different durations, known as EST, EFT, LST and LFT, without affecting the total duration of the project. This implies that the activities on the critical path, known as critical activities, have no float, and the other activities can have potential delay, as to be floated, without affecting the predetermined duration of the project. Thus, float of an activity is to be explained in the next video. Thank you for watching this video. If you find this video is useful and or need more clarification, you may leave a comment about your thoughts. Your valuable comments can make me producing other related videos meaningfully with your support. Thank you in advance for your comments to be made.